Thank you everybody for joining today for our webinar focusing on how to reverse engineer a 3D scanned part. We're very excited to have everyone here. On the line, we have myself, Alex Hussein. Most of you guys probably know me and have met me in some form or another. I'm the co-founder and CEO at 3D Chimera. On the line, we're also have Liz from our team. If you've been on any of our webinars before, you've met Liz. She's in charge of all of our marketing, and she'll be the one fielding any questions that come up along the way. And say hi, Liz.
Hi, everyone. Welcome to the webinar today. Glad you could join us.
Awesome. And then we also have, we're very honored to have Manu Mansi from Polyga on the line. Manu is an expert in 3D scanning, and we'll actually be showcasing some of the Polyga 3D scanners as well as the Extract 3D reverse engineering software a little bit later on the call as well. I don't think your webcam is working today, Manu, is that right? But you are on the line.
Yeah, I'm on the line. Yeah, I'm excited to show you guys how to do reverse engineering. So, yeah.
Cool. All right, very good. So we're going to start with a little bit of background here. I'm going to walk you guys through a little bit of the thought process that we go through as we're thinking about 3D scanning, sort of an introduction into the scanners and the software. And then we're going to dive right into the meat and potatoes, which is going to be looking at how an object gets scanned with these scanners, as well as the reverse engineering process, which I know is what really has driven everybody to the session today. So with that, we'll jump right in. For those of you who are new to meeting 3D Chimera, I wanted to share a little bit about us at a high level. So 3D Chimera specializes really in three things. So we offer 3D equipment, so that can be 3D scanners like we're talking about today, 3D CAD software like Extract 3D, which is a plugin for SOLIDWORKS, which we also offer. We also have 3D printers and materials for 3D printers. So there's a whole equipment side of our business. We work with many of the folks on the line today in that manner. We also have a 3D services component to our business. So if you just have like a one-off project that you need knocked out, whether it's 3D scanning or 3D printing, or even some design help, particularly design for additive manufacturing, our team is here to help with that anytime. So we've got a number of skilled engineers here on staff who actually use all the tools that we sell. And are happy to utilize those for projects to help you guys out on a case-by-case basis. And then, of course, we have a whole consulting component to our business. So whether we're working with your team to figure out how to properly not just purchase a 3D printer or a 3D scanner, but to fully integrate it into your business and make it part of your workflow, we're here to do that. And we can help guide you, of course, with the equipment that we sell. But we're happy to chat about anything relating to 3D, whether it's competitors' products or big ideas. We have a lot of connections in the industry, and we're certainly happy to work with organizations who are pushing the edges of what can be done with this technology. So that's a high level about 3D Chimera. If any of you guys follow us on social media, you'll see that we do a lot of 3D printing. So here's sort of a smorgasbord from our Instagram feed. Different things that we printed relatively recently here. So you'll see lots of SLS 3D printed parts. You'll see big FDM parts. You'll see, production parts and strength parts and detailed parts, tools, jigs, fixtures. Really, the whole gambit of 3D printing is capable with the technologies that we offer here. And a lot of folks think that's really all that we do. But we try to pepper in on our social media feed a little bit about our 3D scanning as well. So you can see some examples of it here. It's not quite as exciting to look at usually as a 3D printed object, but we utilize our 3D scanners to scan things big and small, from super fine jewelry pieces all the way up to actual aircraft. So we've done everything in between. We work with artists a lot. We work with engineers a lot. We particularly work in the aerospace industry quite a bit. So we've got a lot of experience operating the scanners to do all sorts of fun and creative things. One of our favorite stories is that second image that you see on the screen there. That's actually us 3D scanning a tortoise shell, which we did for a television show you guys might have seen on Nat Geo called Dr. K's Animal ER. This particular tortoise was unfortunately run over by a vehicle during Hurricane Irma. And we were able to 3D scan the shell and then use tools in SolidWorks to actually do reverse engineering of the shell and completely build a prosthetic component that goes right on the top of that. And he was able to wear that for a few months as his shell healed, which was pretty an amazing experience and a good example of the type of thing that can be done even non-traditionally, utilizing these types of reverse engineering tools. So a lot of times when people are thinking about 3D scanning, they're not quite sure like what the best applications are for it. They know that there's maybe one application that's tugging at your heartstrings. Maybe it's a reverse engineering for a part that is in a product you have that maybe is no longer available. We see this a lot in aerospace where a component that's needed, a critical part, is just no longer available. Maybe the vendors don't have it anymore or have gone out of business. In fact, just recently, the U.S. Air Force hosted a competition called the Advanced Manufacturing Olympics. Some of you guys might have had a chance to see that. 3D Chimera was honored to participate in 2 different categories in that competition, and we utilized our technologies here to actually help the Air Force reverse engineer some components that are no longer available. And then in that case, we actually used 3D printing to find an alternative source for that. So it was a very cool project and a good example of what you might do with reverse engineering. There are a couple other applications that we see in 3D scanning that don't always come top of mind. So one is 3D scanning for archival. So this is particularly important for artists or researchers, archaeologists, paleontologists, people who are building really unique one-off things that they want to have a digital record of, whether it's for future reference or for posterity in the case of archaeology, or maybe to study something more closely where it's too delicate to touch, but once you digitize it, you can zoom in on every nook and cranny and really study the details. Archival 3D scanning is a very interesting application. And one that might be interesting for your organization. Another place where 3D scanning is commonly used is in metrology. So in metrology, we're really looking at parts for inspection and for quality. We're trying to check for dimensional accuracy and compare that to 3D CAD data. A lot of folks are, of course, doing metrology now. Traditionally, this is done with a CMM where you're selecting a few points and getting a couple measurements. Of course, with 3D scanning, we're taking millions of measurement points. So the data isn't just like a small amount better, it's thousands of orders of magnitude better in terms of the quality. And we're able to really interpret that data and do full 3-dimensional comparisons against the original data. That's a great application. Certainly, if that's something you're looking to do all the time, every time, that directs you to a certain span of 3D scanners that specialize in that space. If it's something that you need to do occasionally, just about all the scanners that we're going to offer are going to have plenty of accuracy and precision to them to allow you to do that for, let's say, a first article inspection or something along those lines. Maybe a critical failure you're having that you need to study. You can absolutely do that. And the fourth is what we kind of invented this category. We call it reference data. And this is actually where I see engineers utilizing 3D scanning the most. Sometimes we kind of call it reverse engineering, but it's not quite the same. And if we think about that tortoise example, it's a perfect example. So we 3D scan the tortoise shell, not to like remake a shell, but rather to build something on top of the shell. So we needed to create the reference data from that shell and then interact with our CAD model in order to allow us to build something unique. So we see people in the automotive industry, let's say, scanning the rear end of a vehicle, not to replace the trunk, but to design, let's say, a spoiler or fin for that vehicle. There's tons of applications like that. Maybe in aerospace, you're scanning a component to add a sensor or to add a new a version of your product that needs to mount to that particular model of vehicle. So there's lots of interesting ways to create reference data with 3D scanning and utilize that that don't always come to top of mind, but certainly you do need to find ways to take that data from the 3D scanner and get it into your CAD tool. And that's what we're going to talk about today. So 3D scanners are going to generate by default an STL file, which is going to be a mesh-based data. Most of our CAD systems, and we'll focus on SOLIDWORKS today, are able to import those and kind of look at them. There are some basic functions you can do, but without specialty tools, you're not really able to easily work with that data in order to do what you need to do with it as an engineer. And so here, We're going to talk a little bit about Extract 3D today, and we'll get to that in a moment. So the next question people always ask me is, well, then, what's the right scanner for me? And unfortunately, the answer to that is it depends, right? So here at 3D Chimera, we always are going to start with your application. So if you guys have ever talked to me, it doesn't matter if we're talking about 3D scanning or 3D printing or a service job, the first question we always ask is, what are you trying to do? And once we can understand that, then we can start to kind of navigate the options that are out there in order to find the best solution for you. So when we're thinking about 3D scanning, some useful background knowledge is that there are broadly like 3 form factors for 3D scanners. So tripod-based 3D scanners. These tend to be super, super accurate. Often they're pre-calibrated, ready to go right out of the box. You point it at your object and you can scan. They often have an automated turntable, which is like super amazing. So you just put this object on here, you hit scan, you literally walk away, and the software and the scanner rotate the object and will get you 3-dimensional data within just a few minutes. Those are great solutions, and they work for many, many customers. There are also handheld 3D scanners. So a handheld 3D scanner is going to kind of be like you're sort of painting the surface digitally in order to generate that 3-dimensional data. We have some handheld 3D scanners we're going to talk about today. These give you a lot more flexibility in what can be done with the scanning process. Of course, because you're moving around in space, you're going to have a little bit of less accuracy, but in the case of the Polyga scanners, it's still better than just about any other brand of scanner out there. So we'll talk a little bit about that in a few moments. There are also ARM-based 3D scanners. You guys might have seen these before. These are sort of an artifact of the old portable CMM-based solution. So these are utilizing those arms to establish 3-dimensional coordinates in space and then create the 3D scanning off the tip. So those are the form factors. And there's a couple like raw technologies to understand. So there's structured light, which is where we project a pattern onto an object, and then we interpret that pattern as 3-dimensional data. Usually those patterns are with either white light or blue light in order to capture the data. The second way that we do 3D scanning can be done with lasers. So this is really popular a few years ago. There's still a few laser scanners out there. There's lots of good things about laser scanners, but you tend to get a little bit better accuracy with structured light. So the more critical the dimensionality is, the more commonly you see structured light as the key technology. Then you have photogrammetry, which right now you guys can do photogrammetry. Go grab your cell phone and snap some pictures around an object. They're cloud-based softwares that you can upload those images into and construct a rough 3-dimensional representation of an object. This works really good if you're trying to like grab an image for a video game, not so much if you need the precision for an engineering level part. And then you have that probing with those arms like we were talking about. So you can see that on the left-hand side there. And what we're seeing is that's pretty much like the least popular direction that folks are going these days, just because you're really constrained physically to a particular space and size. So what we're really going to talk about today is going to be structured light. So all the scanners from Polyga are going to utilize structured light. Like I said, this is an optical process for projecting a pattern onto an object. It's actually really simple. It's like literally a projector and a camera. In our systems, most of them are going to be built in. So you're projecting the pattern and you're using a camera. In fact, we have one system from Polyga, the Carbon series, that has literal cameras and projectors that you can move around on a rail and make adjustments. It is that simple. The magic, of course, comes into the software and how we map that data together and how we take those images and interpret that as 3D data. That's really where Polyga steps far apart from the pack and creates a really incredible offering to get super high quality 3D data. And we'll get some examples of that in a moment. So across the Polyga line, there's actually quite a lot of 3D scanners. So the row at the top there are the compact series of 3D scanners. So all of these scanners are going to have preset calibrations between the cameras and the projectors, no adjustments or calibrations needed from the end customer. So you just grab the scanner, point at your object, and go. Now you'll notice that the different objects there, or the different scanners there, are designed to scan objects at different sizes. So the S1 is going to be your most affordable and your most flexible system. So that one's going to give you sort of the broadest quality results. Still very good quality for just about every application. But if you need that like super high level precision for, let's say, a macro 3D scan of something super, super small, you might look at the C504. Or if you're looking at like super giant parts, maybe like a car door or something like that, you might look at like the L6. So there's quite a bit of variety there in the compact series. Then you have the carbon series, which is in the second row below on the left. The carbon series are basically attached to a carbon fiber rail. That's where they get their name. And on that carbon fiber rail, we have a camera and a projector. You can adjust that relationship of the cameras and the projectors, which allows you to tune it for very small objects or for very large objects. Obviously, that flexibility gives you a lot of control in the process. It also drives the cost up a little bit on those systems and makes it so that the calibration is a little bit trickier. But if you want ultimate flexibility, the carbon systems are definitely the way to go. And then we have the Polyga H3, which is on the far right-hand side. This is a brand new system. The Polyga H3 is a handheld 3D scanner, so you can kind of point and shoot. It also has the added ability to function exactly like a tripod-based scanner, which is like the compact series as well. You can use it in either configuration, and there's really a lot of flexibility to that. Right at the moment, that's kind of our favorite scanner that we're using these days. Here you can see some examples of objects that have been scanned with the Polyga scanners. All of these images in particular were done with the H3. So if you can believe it, some of the compact series can actually get even more precise than this in terms of the data. But we find that for most folks, this is about as good as you need in terms of 3D scan data. We're talking about really close accuracy, really high quality, and data that allows you to do reverse engineering in a pretty nice way. So usually when we're talking with folks who are just starting out with 3D scanning, the H3 or the S1 is really where the conversations are focused. So either you're looking for that extra precision at kind of a lower cost, and that's where the S1 makes sense, or you're looking for the ability to have a handheld scanner that gives you crazy precision, and the H3 tends to be the favorite at that point. Of course, if you have a very specialty application, one of the other scanners kind of bubbles to the top there. But you guys aren't here to talk about scanners. What you guys really want to learn about more is reverse engineering. So when we talk about reverse engineering, you have to think about what you're going to do with the data. So when you capture the data, it's going to be this STL. We've got to get that into CAD. So if you guys have ever tried to do this before, you know that this is a nightmare, right? When you grab that data, maybe you've outsourced it to a service bureau, you've paid a fortune for it, they told you everything's going to be great, and then you get the STL and you go, what can I do with this? This comes in, you're using SolidWorks often as a graphics body. You can't grab the object, you can't spin it, you can't cut a cross section, you can't put a hole in it, you can't do anything with it. Now, SolidWorks has gotten a little bit better at that over the years, but as far as actually going in and getting useful data out of it, it's not super helpful on its own. So Polyga went out and actually developed a totally custom software. It's called Extract 3D. It's an add-in for SolidWorks. So basically, if you're a SolidWorks user, you can purchase this add-in and basically have it active on your Cebus SolidWorks. What it's going to do is give you like a new banner across the top on SolidWorks, and you're going to get a whole new set of tools. These tools are going to allow you to cut cross sections and to actually start to rebuild that geometry so that not only can you turn it into something useful in SolidWorks, you can actually capture the original design intent. Likewise, if you've done scanning, usually you don't scan something that's perfect, right? You're going to scan something that maybe in the case of reverse engineering was used in the real world. Maybe it's got a dent on that bumper of the car. And you don't want that dent, of course, when you're making your perfectly designed, let's say, spoiler for the back of the vehicle. Or maybe you have an object that was damaged in use. You want to get most of the dimensions from it, but you don't want to recreate that damaged area. So you're going to have to rebuild that data and capture the original design intent. And this tool is precisely what will allow you to do that. And we're going to focus a little bit more on that here during our live demo. So at this point, I'm going to turn everything over to Manu. He's going to show us a little more about the scanners as well as the software. And okay, with that, I'll flip it over.
All right. Thanks, Alex. Can you guys hear me okay?
Yep, absolutely.
Awesome. Okay, I'm just going to share my screen. Okay. Yeah, wow, that was a great introduction about Polyga. Thanks for that. And I do not have much to add about, regarding Polyga on what we do or on the line of scanners. I mean, Alex has done a great job about it. Thanks for that. And also, my name is Manu, and I work as a 3D scanning engineer for Polyga. My main responsibility is to assist the customers for the scanning and 3D scanning and reverse engineering needs. And I also hope everyone's family and themselves are doing well in this pandemic situation, and we all can just hope that things get sorted in the future, right? So what I'm essentially going to show you right here is that I'm going to show you how reverse engineering is done. So I would like to show you how to capture the data first, and then how to use the captured data to be used as a reference sketch to create a 3D CAD model. So I'll be first showing you how to capture data by using a 3D scanner. So what I have here is a pre-recorded video of a 3D scanning of pre-recorded video of a scanning of a 3D model. So what I have here is a mechanical part of a bike. So I have the video so that it's easier for me to explain while the workflow progresses, right? So I'm just going to go ahead and play the video and talk about it while the workflow progresses. Awesome. So what I have here is a compact C210. It is a desktop 3D scanner. It has a monochrome. It has two megapixel monochrome cameras. So gonna go ahead and forward that video. But before the 3D scan, the first thing that we have to notice is that we need to decide on the exposure and the focal length of the cameras. So exposure is basically the amount of light that reaches the sensor. So FlexScan comes with a couple of tools, which is basically visual cues for you to know like how exactly to 3D scan. So for example, in this video, you can see that the object is red in color. So these two screens, what you see here is the live video feedback from the cameras of the scanner, right? So once you see that it is red in color, it means that it's overexposed. So you need to make sure that this is not in red or blue. So right now it has overexposed. So that means the exposure is around 10. And you need to reduce the value. So I'm just going to go ahead and reduce the value to maybe like 0.5 or something lower. So what we have now is blue. So this means that it's underexposed. That means there's not enough light reaching the sensor. So you need to have an optimum exposure, which is between the 0.5 and 10. And I found that 2 is the best exposure for this object. So once you have that, you also have to make sure that the object is in focus with the scanner. It's mainly because it's just like photography, right? I mean, the object has to be in focus with the cameras inside the sensor. So here, this 2 red crosshairs, which is basically on the video live feedback. These crosshairs are basically to help you adjust the object so that it doesn't focus the scanner. So you need to make sure that these red crosshairs, they point towards the same part of the object. So once we make sure that the exposure and the focal length is correct, you're good to scan. So I'm just going to go ahead and show you how to scan. So I'm just going to hit scan button, and this is what you get. So you get a mesh data which is not fully complete. This is mainly because first thing is that there is no enough light reaching the corners of the object. So if there's no light reaching the corners of the object, you do not get scan data. So your initial scan data will look like this. So what I'm going to do is I'm going to change the orientation of the object a bit. So it's basically changing the angle of the object at which the scanner is looking on it, right? So when I do that and take a second scan, I get a mesh which is slightly different from the first mesh. Now I'm going to put them both together and align them together. So you get a more complete mesh. I know you're not able to see a lot of difference between these two because the change in angle is not a lot, but yeah, I get the idea, right? So this is how it's done. And I'm just going to go ahead and delete these, and I'm going to use a rotary table. So the mechanical part that's sitting in front of the scanner, which is on the rotary table, is used to rotate the object in 360 degrees. So how exactly it works is that it does predefined intervals. It does a predefined rotations like at set intervals, and it takes scans in between those intervals. So let's say we want to do 6 scans. So the rotary table will do a scan, rotate 60 degrees, take a second scan, and goes on till it completes the 360 degrees. So you get the complete mesh. I'm just going to go ahead and show you guys on how we do it. So I've selected 6 scans. So if you're having a 360, it's basically 60 degrees per rotation scan. Also, what FlexScan does for you is that it aligns all the objects, it aligns all the mesh data for you. So it's basically like a one-click process. So once you have all the settings done, you can just keep the object in front of your scanner on top of the rotary table, and it does all the scans for you and it aligns for you. So you don't have to really do a lot of intervention to get your scan data. So it's done 4 scans already. This is real time. We have not really sped up the video. We just want to show you guys how exactly and how fast it is to scan these parts. So 6 scans, and there you go. That is a complete mesh of the top of the face up of the mechanical part. So now I'm going to change the orientation and probably do a face down. Before that, I'm going to combine all these scan data into one, so that's easier for me to work with, because they all look similar and I don't want to really confuse myself on which parts I'm working on. So I'm just going to click on combine. It's basically like zipping all the files together. There you go. And I'm going to change the orientation. Now it's probably face down. And I'm going to hit scan again. Same process. So it will do 6 scans at 60 degrees, and it will combine them and give me another mesh data, which is of the face down. And so I'm just going to do 2 orientations for this part because it's a fairly simple part. As the complexity, as the geometry of the object gets complex, you need to have different variations. You need to have different angles. You need to add a little bit of tricks to get a better scan. So this is a fairly simple one. So it just took me about a minute or 2 to scan this item. And there you go. That's the second scan. I'm going to combine them and put them next to each other. So you can see the difference, right? So this is face down and face up. So I can just bring them close to each other, align them, make them into a single file. So I get the complete the mesh data for the part. There you go. So as you can see, there's a couple of holes on the mesh data. This is mainly because the mechanical part that we use to scan is a bit worn out, and the bare metal is black in color, so the paint is worn out in a few areas. So the thing about the light structure scanners is that if there is a black, if it's black or if it's anything shiny, it's really difficult to get the scan data. So this is why we have a couple of holes on the mechanical part, right? So I'm just going to go ahead and finalize. When you finalize, you basically do resampling, you do a little bit of hole filling, you do a little bit of smoothing. So I'm just going to go ahead and do that. Make sure all the settings are correct. Click on OK. So we finalize. So this is the FlexScan also comes with a couple of post-processing tools, something like hole filling. So I can go ahead and show you how to hole fill. So this is the hole filling tab, and what we do here is that we can set the slider to full and do an autofill, but you can see all the threads also get filled because there's a couple of holes in it. So I mean, this is not what I really want to create a scanner of. So I'm just going to go ahead and make that into something like this, and I'm going to manually select these holes and click on fill selected. So it looks much cleaner than before. Right, that looks good. Yeah, so this looks ready to be used as a sketch to draw a CAD file out of from. So I'm just going to go back to mesh editor and use the same mesh to export it to a file. So I've selected .stl file because that's what I'll be working on in SolidWorks. So yeah, that's about it. So that's the first step of reverse engineering, that is to capture the data. So I have the data now saved as a .stl file. Now the second step is to use this captured data to create a CAD file. So I'll be using Extract 3D. As Alex already spoke about it, I'm just going to open up SolidWorks. I might have to stop the share and start again. Hey, Alex, can you see my screen okay?
Yep, looks good still.
Okay, awesome. All right. So I'm going to open the open Extract 3D. I'm going to create a new part and click on Import. And I'm going to select the scan data. So this is the same scan data that we just used, right? And I'm going to select inches because that's what I scanned it in, so the units. So this is the same part that we just used. And I'll be using this to create a CAD file now. So I'm just going to click on Mesh Info. I just want to change the color so it's easier on our eyes. Yeah, just added some contrast. Yeah, it looks much better. So yeah, I'm going to begin with creating reference planes. Basically, the scanner doesn't know where the part is in space. So like all the reverse engineering process, I would have to start creating planes. So I'm just going to do that. Create plane. That's creating a plane. And there you go. And let's use that. What I'm going to do now is I'm going to slice. So slicing is basically so that I can see all the contours of the object. So I'm just going to click on opposite sides, move. Yep, looks good. Next, I will draw a line on this plane. Click that, select it, Extract 3D, snap. So Extract 3D has two tools. One is snap and fit. So snap just throws a line on top of the existing lines of the mesh data. So for example, if I select a line and I click on snap, it just goes onto this line, right? The fit is similar to snap, but it averages the line. So let's say using an arc, I find fit to be more useful. And if I'm using a line, I find snap to be more useful for me, but it really depends upon the user. Anyways, yeah, so I'm going to go ahead and draw this line. And I'll select this one too. Use snap. Oops. Yeah, that should be good. Okay, I'm going to use this as an origin. So I'm just going to go ahead and click on that so you can see the object. There you go. Okay, just going to go back to features, select this line and this plane, and create a plane that's normal. Oh, I'll exit the sketch. Yeah, plane. Okay, perfect. Now I think it's time to create a coordinate system. I'm just going to go here, click on coordinate system, select this as my origin, and I'll take this as my x-axis, flip it. Yeah, that looks good. So I have my y-axis set correctly, the x-axis and the z-axis looking towards me, so that's good. Yeah, and I'm going to click on OK. Go back to Extract 3D, select my mesh data, click on Use Coordinate System, and select the coordinate system. So you see that the object has snapped out of its position, right? So this is what we want. We want to set the object its new coordinate space. So click on OK, and we have it all done. So we don't need these anymore because we already changed our coordinate space. And click on yes, yes, yep, there you go. So now we have the object all set to be reverse engineered. Yeah. Next, what I'm going to do is I'm going to do something similar. I'm going to create another reference plane by selecting these points. And you also have a couple of other options to create a reference plane. So you can either do a single point, mesh select, use spline, or copy plane. I'm just going to go with this one. And I'm going to select 3 points more, or how much ever you needed to. Create. There you go. And I'm going to click on this and do a slice. And I don't want a slice through this cross section. I mean, I want the cross section, but not this direction. So I'm going to click on opposite side and click on move slice and do the same thing that I did before. Yep. So now I get all the contours of the object. All I need to do is to draw along these lines, right? So it's going to be a bit boring for everyone who's watching, but I'm sorry about that. Yeah. There you go. I'm just basically what I'm going to do is I'm going to draw a couple of lines and arcs and use them all together. And you get the idea. There you go. This one. Go and draw a line here.
So I think this is one of the things that might be new to some folks. So a lot of times when we're thinking about 3D scanning, it's common for folks to think that the scanner is going to like magically create this like perfect 3D CAD data for us. And as you can see, the scanner does create something that we can just drop right into SolidWorks and start working with. But if you want to do any legitimate engineering work, we can't just simply go with the scan data. We've actually got to build out a 3D CAD file that has parametric values to it, that has sketches in it, that have planes in it, that have references in it, so that that data is actually useful to us. So
exactly.
Yeah, I think that's one of those things that it can be surprising to folks who haven't done this before, that this work needs to happen, but it is really what makes the data useful.
Yep.
So yeah, the best way to think about 3D scanner is not so much like a magic replicating tool like we see in Star Trek, but rather it's a tool to basically allow us to now work with that data in 3D. I mean, of course, this particular geometry is relatively easy. We might be able to measure it with a caliper in some places, but there's a lot of complexity as well, right? Even just that little tiny radius you're doing right there. I mean, how would one legitimately measure that? Maybe you could grab a pin gauge or something to try to do that. But you end up making a lot of educated engineering guesses. Here, that takes that kind of risk out of the equation and allows you to really focus on getting the details that actually matter for the design.
Yep, you're right. This is the boring part of reverse engineering, I'd say.
Right.
Yeah,
it's not particularly hard, right? It's just like a little bit.
It's not particularly hard. It's a bit time consuming, but you get the benefits towards the end of it. But yeah, it's a bit tedious. I mean, it really depends on the complexity of the object. This is really easy to work with, so it's no problem. But I mean, as the complexity increases, it gets really time consuming. So this entire part would take about close to 1 hour if you're not really proficient in SolidWorks. So it does take for me, I mean, I'm not really proficient with SolidWorks, but it does take me quite some time to do this. Let's say like close to 1 hour if I want to get the whole thing done. I won't be doing the whole thing now, but I'm just letting you guys know of how it looks like. Yeah.
Yeah, I don't know if we could handle a whole hour.
Yeah, exactly.
You are very entertaining, but
I try to be. Yeah, we're almost done. And
I want to remind folks here, if you guys have questions along the way, please leave those questions in the Q&A. I know Liz is gathering those questions, and we're going to address those in a moment. In fact, maybe Liz, this might be a good time. If there are any questions that are out there now that we might be able to address, do you have anything that's come in yet?
Yeah, let me take a look and see what we've got. One moment. Okay, so a question I think we'll probably see in different ways is what license of SolidWorks or what year release of SolidWorks does Extract 3D work with? And to append that, is it backward compatible to older versions of SolidWorks?
That's a good question.
Yeah, so SolidWorks, Extract 3D is compatible with 2017 onwards. So we officially support from 2017 to 2020. I mean, we do have customers who use SolidWorks from 2015 version onwards, but we do not really officially support them, right? So yeah, that's what it is.
Yeah, and I know a lot of folks who work with SolidWorks might hold off on upgrading a license in a particular year just due to whatever licensing costs there might be associated with that on a yearly basis. So yeah, that's a good point. And one thing that is kind of new for 3D Chimera is a lot of you guys know that we've used SolidWorks for years. I mean, I'm a SolidWorks professional. I ran the SolidWorks user group in Miami-Dade for quite a while. But we actually just came on board with SolidWorks as a reseller or distributor as well. So if any of you guys are in the Florida or Georgia area and you need to renew your license, or you're looking to add some seats, or maybe you're an Autodesk user and you're looking to do some reverse engineering, and this tool looks like what you need, I would be happy to work with you to get a new version of SolidWorks up and running and help you to find a solution that can get the job done there.
Great, thanks for that, Manu and Alex. So another question that is relevant to this that we've had is there a difference in which scanner works best for large objects or small objects, or are they more universal?
Yeah, so definitely each scanner is going to have strengths and weaknesses, just like any tool. So, Manu, what was the scanner you guys selected for this again?
So we used the C210, a compact series, one of our scanners. Yeah, C210. So we have a smaller scanner. I mean, the scanner which is capable of scanning the smallest part is called the C504. So the C504 is a macro scanner. It can scan anything between 0.5 centimeter to 3 centimeter. And we also have the L6, which is the scanner which can scan the largest of all the object. It can do something with like a shoe, or even bigger than that. I mean, but obviously, the larger objects you scan, the lower resolutions you get, and the lesser details you have. So it really depends upon your application on what exactly you need to scan. So you need to pick the right scanner for it.
Right. And what we've seen, Manu, is that really the kind of the most flexible scanners in the lineup in terms of adjusting for different sizes are either on the high end, the Carbon series, or on the more affordable end, the S1 or that H3. Would you agree with that?
Yep.
Okay, cool.
So what I'm hearing is that you're sticking to the premise that it depends on the application.
Yes, that's right.
Yes. Yeah, that's right, Liz.
So Manu, it looks like you took this sketch there and you were able to
Yes,
extrude from that shape.
exactly. So I just made a small part of this reverse engineering CAD file, and yeah, that's what it looks like initially. I mean, obviously, you can add a couple of other features as well, but I just had a quick one for you to know how to do it. And you can just go ahead and, I mean, yeah, I did that so you guys know how it looks like. So yeah, that's pretty close to what it is. And yeah, obviously, I'll just show you guys on how it looks, the actual file. I have it saved here so you guys can see. There you go. That's what the complete reverse engineering looks like. So I have a side-by-side comparison. So this is what we have scanned, and now this is what we have. So this is the step 2 of reverse engineering, that is to create a CAD file out of the captured data. So once you have this CAD file, you're all ready to manufacture, which is the third step of reverse engineering, and that's what it is. So I've showed you guys on how to capture the data using a 3D scanner, use the capture data to create a CAD file, and yeah, there you go.
So one of the things I'd like to highlight is if you look on the left side of the screen there, there's a full feature tree, right? Because you built this out as if you were basically building an object from scratch using CAD, except in this case, instead of grabbing maybe sketches off of a piece of paper or numbers off of a caliper, you're actually referencing the original 3D scan data. But it's a full-on feature tree. So if someone was to say, we often see customers come to us and say, like, I want to scan this, but I want to change the size of this hole, right? Could you go in and change the diameter of one of those holes in a model like this without it destroying everything?
No, not really, because everything is dependent on each other. So I cannot.
Okay.
Yeah, you know how it is.
Yeah. So, but we could fill in an area and then recreate a hole, right?
Yeah, that you can. Yep.
Yeah. And I think that's really the power. So as folks are looking at 3D scanning and trying to figure out, how you can use it, this is really what you're up against as far as workflow goes. And there's a number of different reverse engineering tools out there. Extract3D is like pretty much the most affordable tool we've seen out on the market. Some of you guys may have seen some others out there. They can be very good. Maybe Geomagics, for example, but you're looking at 5 to 6 times the cost of this software in order to utilize a tool like Geomagics. And a lot of times you're really buying more than you might need. So if this looks like what you need, then this is the way to go. If you think you need a lot more detail, there are other tools out there. But we find that most of our customers are able with this tool. And there's another tool that we often pair with the Polyga scanners, which is called Quick Surface 3D, which works really well with organic geometries. Between those two tools, you can pretty much reverse engineer just about anything that you need. Those are the tools that we use in-house here for all the projects that we do at SolidWorks. Well, at 3D Chimera. So with that said, Manuel, really appreciate everything you're able to show us here. I think I'm gonna show my screen here.
Yeah, I'll just stop mine. Yeah, sure.
Okay. All right.
There you go.
All right. So I'll go ahead and share my screen again. So we're just about to round out the session here, guys. This is the time for question and answer. So Liz, do you have any other questions that have popped up that we might be able to address?
Yeah, I have a couple more. So one of the ones that's come up is, can these Polyga 3D scanners scan either clear or shiny objects?
Yeah, that's a great question. So in general, with 3D scanning, clear, shiny, and black are kind of our 3 enemies. So like if you have something that's black, clear, and shiny, like that's the hardest. The good news is that there are some tricks that we can do to get around that challenge. Probably the easiest thing to do is we have a 3D scanning developer spray here at 3D Chimera. It's available right on our web shop. You can spray that on the object. It goes on really quickly, and it basically makes the surface like a matte white color. And because of that matte white color, we're able to very easily 3D scan the object and get the detail to come in on the scanner on the first shot. So of course you can fill the holes in like Manu showed us today on the scan, but that's another technique, is to just simply go in and do a little bit of surface preparation prior to scanning the object.
And to that end, are scanning targets necessary with the Polyga 3D scanners?
Oh yeah, it's another good question. So it sounds like we've got some folks who have done some 3D scanning before in the audience. That's awesome. I love to see that. So there's lots of scanners on the market that absolutely require like targets or stickers that you place on the object in order to create like I call it a constellation of references in 3D that kind of give the scanner some frame of reference as you're capturing the data. With these scanners, that's optional. So if you have a really difficult to scan object, there are targets available, and we can enable that in the software. But unlike many of the competitors, and in fact, lots of the competitors that cost significantly more, it's not required whatsoever. So you've got really a lot of flexibility there. So if you have an area where if your object is too small or too detailed to receive a target, you can utilize the scanner on its own to capture that. Perhaps if you have like a big flat area or an area that doesn't have a lot of three-dimensional geometry on it, that's really where the targets help, because obviously if it's a flat area and there's not a lot of 3D data, we do need to create something for the scanner to see as it captures that area of the scan. So that's really the strength of using the targets in that area.
Mm-hmm. Great, thanks. Hey, Manu, before we wrap up too, I've got a question specifically for you. How much time did it take you to do the 3D scanning versus the reverse engineering? And what was the total time bundle that it took you to complete this project?
Okay, so for the object that we scanned, it took me about, so from the initial setup to scanning to get the .stl file, it took me about 5 minutes maybe because I had to calibrate the scanner. I mean, not the scanner, the rotary table. I have to make sure that the settings are correct, that is exposure and the focus length, and stuff, the clearing distance and stuff like that. So in total, maybe 5 minutes to get the scan data. And to reverse engineer, maybe the whole thing took about close to 1 hour. So you're talking 5 minutes for scanning and 1 hour for reverse engineering. I can also see that they asked another question saying, what is the technology of the used scanner? So we used a light structured scanner. All our scanners are light structured scanners, including the H3. So yeah.
Great.
I guess that answers it.
And then did you achieve the required tolerances for this part once you were done with the reverse engineering?
No, I mean, I haven't really tested the tolerances yet. So I guess I can share that later if somehow possible. I haven't honestly done it.
Yeah, but there is a way to compare the 3D scan data to the CAD, right? So,
yes, Extract3D comes with a mesh deviation feature, so you can use that to see the tolerances and I mean how much you achieved it.
Right. Yeah, and a lot of times when you're doing a 3D scan, this is also like one of those places where we get a lot of questions about how accurate the scanner is and what level of detail you can get on the scanner. At the end of the day, accuracy of course matters and precision matters, but at the same time, so does understanding the design intent of the object and making sure that the data is appropriate for the end application. So in this particular case, we may have only had this one part and we're trying to recreate that. But you know, let's say we look at a hole, for example, one of those holes could have been slightly ovalized from being used, you know, over an extended period of time. You mentioned that some of the paint was chipped away in certain areas. So when you look at the scan data, the scanner is going to obviously show those paint chips. It's going to show the ovalizing on the hole. And when you look at the comparison of the mesh data to the CAD, there will be a deviation there. What I really love about the approach with Extract3D is it gives the power of that reverse engineering process back to the engineer. So we're not having some type of like AI magic, like trying to think like an engineer. We have like an actual engineer's brain, fingers, and CAD skills in the middle working on that data. So the precision you have in your reverse engineered part is precisely what you want it to be as an engineer, capturing the original design intent rather than what the software generates. We're only limited by what we want to do in terms of those measurements. So just like if you had a caliper and you measured an object and it measured, let's say, you know, 1.500352, you probably actually wanted that to be 1.5. And so you would obviously be off slightly from whatever you measured on the caliper, but you know the design intent was to hit a round number or an integer. And so this could allow you to do that. So it depends, obviously. Again, it depends. I think reverse engineering there's a lot of it depends here. And that's because of the engineering part, right? It would be hard to make hard and fast rules about the right way to design a new product from scratch or to utilize CAD to develop something new. There's a lot of different ways to approach a problem when you're looking at tolerances or gaps or clearances or stack ups. You have to consider the manufacturing process and how it mates with other parts. That's one of those things that I always like people to really think about. I love that we saw that question because that's like one of the most common things that we hear is that question. I've also got another question here asking specifically about laser for reverse engineering versus structured light. Laser technology is great. It has some advantages, of course, and some disadvantages. One of the advantages of a laser-based scanner is that they tend to be a little bit easier for scanning shiny surfaces. So just due to the wavelengths, they don't react as difficult with shiny objects. On the flip side, you get more precision with structured light. So whether you're looking at the Polyga scanners or there's some like dedicated metrology scanners that they cost like as much as a house, and those type of 3D scanners almost always utilize structured light as well. That's where you can get that extreme precision. Manu mentioned the macro 3D scanner from Polyga. I mean, the size of objects that can scan is like mind-blowing. What did you say the minimum size was on an object, Manu?
0.5.
Right, 0.5. I mean, like, that's unbelievable, like so tiny. Most 3D scanners, if something is smaller than about a football, you're not going to get any data. And that's usually true on a laser scanner. So, if you needed to scan something small, there's just no chance of capturing that data usually with a laser scanner. But it does depend. Again, you can get that precision. There's going to be some trade-offs there. All right, Liz, were there any other questions? I know we're rounding out our time here.
Yeah, I think we've captured everybody's questions at this point. So if anybody has questions that they think of afterwards, please feel free to reach out to Alex or Manu directly.
Absolutely. On the screen here, you'll see all of my contact information. That is my direct line. So if you dial that, you will get me answering the phone. That's my personal email address. Please don't hesitate to reach out. We really appreciate your time, everybody. I hope that you guys got a chance to learn a little bit more about the reverse engineering process and about the products offered from Polyga. Here at 3D Chimera, we certainly would love the opportunity to work with your teams and help to find the ideal 3D scanning and reverse engineering solutions for your application. So if you guys would like us to have another talk like this with your team, looking at your specific application, we're here to do that all the time. Here during the pandemic, pretty much everything is done remotely, so it's super easy to do. You give us a buzz and we'll set up a meeting for you, and we'll be happy to dive into the details. But anyway, I really wanted to thank you for your time. Your expertise really shone through today, and I think you did a great job highlighting what the Polyga technology can do. So thank you again.
No problem. Thank you for having me.
Absolutely. And Liz, like always, great job making sure that everything went off without a hitch. So thank you as well. And thank you to the whole audience here for joining us. We hope you guys have a great day, and we look forward to seeing you on our next webinar. Bye-bye.
Bye now.
Bye.